Welcome to Robotics Unleashed. Smarter, safer, seamless. Today's episode spotlights 23 breakthrough robotics papers published on July 9, 2025. Discover advances in how robots sense, learn, and interact, from surgical precision to seamless navigation and humanoid control. This journey explores the fusion of artificial intelligence, engineering, and human experience, revealing the themes shaping the future of intelligent machines. Robotics research is transforming technology and society by moving beyond industrial settings into daily life. Recent work blends intelligence, safety, and adaptability, raising pivotal questions about how to make robots trustworthy partners. Today's episode highlights innovations that bring science fiction closer to reality, introducing the robots that are actively changing the world, one advance at a time. Robotics is a rapidly evolving discipline at the intersection of engineering, artificial intelligence, and human psychology. The core focus is on building machines that can sense, plan, and act effectively in real-world environments. Modern robots now operate across homes, hospitals, factories, and other domains. Research spans key areas such as perception, control, learning, and human interaction, with the overarching goal of creating seamless, autonomous, and human-friendly machines. The central theme in current robotics research is human-robot interaction and safety. Ensuring robots are both safe and trustworthy for people is essential as they become more integrated into everyday environments. Notably, Pandey and colleagues demonstrate that a person's emotional state significantly influences trust in rescue robots. Adaptive safety models are now being designed to prioritize user comfort and not just accident avoidance. User feedback and predictability also play critical roles in shaping confidence, while robots must increasingly be able to read and respond to human emotions in real time. Embodied intelligence and manipulation are redefining what robots can achieve. Recent research shows robots mastering complex, adaptive actions through advanced learning methods. Zhu and colleagues leverage hierarchical learning to enable dexterous tool use. Kim's team utilizes soft robotics to develop self-dressing assistive systems, while Sun and collaborators present unified control for full-body humanoid coordination. A key concept is hierarchical reinforcement learning, which allows robots to learn tasks incrementally, step by step. Navigation, planning, and exploration are crucial for robots operating in dynamic and unpredictable environments. Kim and co-authors introduce steerable vine robots capable of navigating intricate three-dimensional spaces. Lee's group advances vision and language navigation to guide autonomous drones through urban airspaces. Wu and colleagues apply deep learning to accelerate the motion planning process. Model predictive control emerges as a prominent technique, enabling real-time planning with safety constraints to ensure robots move safely in challenging settings. Learning-based control and the study of emergence are driving the next wave of robotics innovation. Learning allows robots to adapt to new tasks and environments efficiently. Liu and collaborators employ four-dimensional diffusion models for skillful imitation learning. Vita's team proposes a novel framework for understanding emergence in robot swarms, emphasizing that swarm behaviors depend on both system design and observer perspective. A major focus is bridging the gap between simulation and real-world deployment, ensuring robustness and adaptability. Several key findings from the latest research stand out. Vom and colleagues demonstrate that wrist-based haptic feedback enhances surgical precision. Sun's team shows that integrated control frameworks enable natural, human-like motion in humanoid robots. Liu and collaborators introduce methods for forecasting failures, helping to bridge the gap between simulation and real-world performance. Wu's AI-guided planning methods significantly reduce computation times. Across these advances, the human experience remains central, with robots being designed to adapt to our needs. These advances are underpinned by diverse methodologies. Reinforcement learning is extensively used to power adaptive and multi-stage robotic skills. Diffusion models are implemented to generate realistic and diverse robot behaviors. Model predictive control ensures safe, real-time adjustments during operation. Soft robotics contributes safety and flexibility, making machines better suited for human environments. A common challenge remains, balancing the need for large datasets, precise control, and successful transfer of solutions to real-world conditions. The highlighted paper by Vlong and colleagues in 2025 investigates a novel wrist-based haptic device that enhances force control during teleoperated robotic surgery. This device outperforms traditional fingertip feedback in accuracy without introducing ergonomic issues. Users were able to apply target forces more precisely, though task completion was slightly slower. The approach opens new possibilities for wearable feedback systems in teleoperation and hazardous tasks, and was selected for its direct clinical and design relevance. Sun and colleagues' 2025 work, Unified and Fine-Grained Controller for Humanoid Locomanipulation, introduces a single policy control system that manages both walking and manipulation in humanoid robots. The framework integrates balance, skill learning, and robustness to external disturbances. Experimental results on the advanced Unitree G1 humanoid platform demonstrate that this approach outperforms modular systems in both accuracy and adaptability. This work is recognized for pioneering unified control in complex robotic systems. Wu and collaborators' 2025 paper, Growing Trees with an Agent, Accelerating RRTs with Learned Multi-Step Episodic Exploration, presents a deep learning agent that guides rapid and efficient motion planning. Their episodic RRT achieves a 98% success rate in six-dimensional spaces, compared to 19% for classic RRT, with dramatic improvements in speed and path quality. The release of open-source code accelerates adoption by the robotics community. This contribution is notable for blending artificial intelligence with classical algorithms to achieve real-world impact. Future directions in robotics emphasize the integration of learning, control, and interaction within unified systems. Efforts are underway to make robots more reliable as they transition from simulation to real-world applications. Research aims to enhance emotional intelligence and personalization in human-robot interaction, improve explainability and trust in high-stakes operational contexts, and expand the roles of robots from industrial settings to everyday life in exploration. The synthesis and review presented in this series are powered by GPT 4.1 from OpenAI for research summarization. The narration utilizes DeepGram's text-to-speech technology, with visuals designed using OpenAI's image tools. A human expert has reviewed the content for accuracy and clarity, although some oversights may remain. All references are provided to ensure up-to-date and accessible robotics insights for a broad audience. Thank you for joining AI Frontiers. Subscribe to our YouTube channel to discover more robotics breakthroughs and stay updated on artificial intelligence, robotics, and human-robot collaboration. Join the conversation. Your curiosity shapes the future. Continue to explore, learn, and innovate with us at AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or technology enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.